Okay, so now we're going to talk about aggregations. How do we aggregate data using SQL? So just like in Excel, you can perform aggregations on columns using SQL. Aggregations are coded in the select clause of the SQL statement. So that'll be done in the select portion of your query. For example, select sum sales. Some of the common aggregations that we perform are summing, and that's just going to add all the data elements in that column. And that's why if your column has to be, when you look at that, everything in that column has to be the same data type for you to be able to add that up, just like in Excel. You can do a min, so it's going to return the minimum value of a column. Maximum is going to return the maximum value. You can do counts, and you can do averages. So stepping into the example, we have in this, now we have the sales DB. This is just a fictitious database and table name. And this is just a table with three rows. So business question, please pull total sales, average quantity, and the lowest store number, and a count of item numbers. So I just did this just to show you just the different types of aggregations you could do, and this is how the syntax would look. And this would be the results. So if you look at this, sum sales. So basically it just summed all the sales in the sales column. So we had 10, 20, and 30, that equals 60. Bam. The average quantity, and just average this value, and that's 1.66. We did a min of store number. It's going to go through all the store numbers and find the minimum store number. And store number 1 is the minimum store number. And item count. It counted the items. 1, 2, 3. You notice that we only have 2 actual unique item numbers, but it showed 3. Because we just said count is just going to count each row. Also, we renamed the column to store min, something more descriptive, average quantity, sum sales, or you can just rename it to whatever you'd like. So using the distinct keyword, to get unique values of a column, we can use the distinct keyword. So select store, distinct store number returns a list of unique store numbers. Select count distinct allows us to count distinct item numbers. And this is a way to remove duplicates. So if we had store number, item number, we can say select distinct store number and item number, and it would only get return the unique rows of store number, item number combinations. Okay, so now we're going to get into counting distinct values. So I need a count of item numbers that sold after or on 1/1/2006. So we have select count distinct item number as item count from our table. And here's where we use the greater than or equal to operator, where sales date is greater than or equal to 1/1/2016. And so if you see now, we have an item count of 2 because it went through the data set, even though we had a where filter, and it's going to go through and it's going to return all rows because greater than or equal to, all these dates are equal to that. And we have 2 unique item numbers. And again, we renamed the column to something that made more sense for us, item count. Okay, so here's the exercise. We're going to pull a list of unique zip codes from the store desk table. And in our example, again, the keyword distinct. So select distinct zip code from this table, and this is what we have returned. So now we have another exercise. Let's pull average sales and average quantity for item number 100. Exercise, select average sales. We're going to rename it here, comma, and average quantity. And we're going to rename it here. So if you rename a column to something and you don't have any spaces in the name, you don't have to put the quotes around it. And this is our result, average sales and average quantity. Okay, so we talked about using the group by for aggregations. You're going to use a group by whenever you have a query that contains columns that you're going to aggregate and some columns that you're not going to aggregate. So basically, you're going to be rolling up to a level. So columns that are not being aggregated must be in the group by clause. So columns that do not have a sum, min, max, or average or count, they must be in the group by clause. This tells the system that we're going to roll up to this level. The group by comes after the where, and if there's not a where filter, then you can put it, it's just after the from statement. So if we look at this query, we have select store number, and we're going to sum sales from our store sales table. If you look, store number doesn't have an aggregation being performed on it, so we have it in the group by clause. So we're basically rolling sales up to store number. So store level sales. So now we have a business question. For each store, can you provide total sales and how many days the store had sales? So basically this report is going to have store number, total sales for that store, and how many unique dates that the store had sales. So here's how that query would look. So we would have store number. We're going to sum sales and count distinct sales date. And we're renaming this into total sales and date count from our store sales table group by store number. Oops. All right, come on. What did I do? Boom, boom. Sorry about that. And here's our results. We have store number. See, it didn't aggregate store number because it's not in, because we don't have an aggregation being performed on it. So we have store number, sales is going to be aggregated, and date is going to be aggregated. So if you look, we have one row for store number because we have one for store number 1 because we're rolling up to that level. So store number 1, we add the sales, 10 and 10, we have 20. And we have 2 different dates. It just counted the distinct dates. Again, since we're rolling up to the store number level, store number must be in the group by clause. And I just want to reiterate the importance of the group by clause because a lot of people they have trouble understanding why do you need to do it. And that's just telling the system, hey, we're going to roll up these other columns to this level. Now, intuitively, you would think that the system would know, hey, if I'm not performing an aggregation on it, then I automatically should roll up to that. But it's just something in the, I guess, ANSI standards where you have to say, we have to put it in the group by clause. Again, these 2 columns are being aggregated, so we don't include them in the group by. So exercise. We want to roll sales up to an item number level from the store sales tables with a count of stores that it sold in. So basically, we're looking for this report. It'll be item number, total sales, and a count of stores. So again, item number, we're going to sum sales to get our total sales, and we're going to count distinct store number. And we're going to group by item number. Before in our example, we were rolling up to store level, but this time we're going to roll up to an item number level. So we have another just example. I need total sales and sales date counts by store item number. And we're going to sort from smallest to largest store number. So this time we're just going to add an order by to this, to our report. And this time we'll have 2 items that we're rolling up to. 2 columns that we're rolling up to. We're rolling up to this store item level. So for each store item combination, we want to roll up sales into a count distinct date. This is our report. And if you look, we ordered by 1. So we ordered by store number. So our result set, if you look over here, it's ordered by the store number column. date count of 1. And the reason, even though this store had 2 date counts, because we broke it out by item, so that store item combination only had 1 date count. So store number 1, item number 100 is on this date. Store number 1, item number 999 on this date. So we had 2 different dates, but because we brought it back by store item, we only get a date count of 1 in this field. Again, both store number and item number need to be in the group by clause. So exercise. I need average sales by item number and date ordered by item number, then date, both descending. So in this report, we're going to have columns item number, date, and average sales. And so we're going to have order by with 2, order by clause with 2 different columns in the order by section. So item number, calendar date, average sales. We're renaming the We're renaming the column from this table, group by item number and calendar date, because again, we're not performing any aggregations on these columns, so they have to be in a group by statement. Then we're going to order by item number descending and then calendar date descending. And so these are the results. And descending, again, is from largest to smallest. So it found item number 304 is the largest item number, sorted by that first, and then it went to date and sorted by date secondly. Using aliases. So again, we can use aliases to save time from having to type complete column names. The position number of the column in the query can be used instead of the column name in the group by and order by. And so in this option may not be available for all RDBMS systems, but a majority of them will allow you to do this. So in our example query, we have a group by statement where we have the actual column name, store number, and item number, and an order by store number. So here that's replaced with group by the first column and the second column, which is store number and item number, and we're going to order by store number. It just saves you some typing. So just some best practices for formatting your queries. You can type this query all on one long line, but to me it's hard to read in that format. So some of the best practices, use indentions, and use new lines. So for me, when I separate my columns on new lines, and I indent over just to make it readable. I definitely put my clauses on different lines, and I end with semicolons. Also, renaming aggregate columns is a best practice. It's something that is more descriptive, especially once you start doing calculations. You want to rename that column because you'll have a long calculation that would show up in the header of your column. Okay, so where you are now, you can pull a list from an attribute table. You can perform aggregations on columns. Oh, I need to fix this. You can sum, min, max, count, and average. You can sort data results. And so next, we will learn how to take these results of a query and store them in temporary tables in the database. Please email me, like, or comment if you have any questions, and I'll see you in the next session.